Ja. 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 Yeah. Okay. So it's still everybody Dutch, or some English people entering the room? English, please. Okay, we'll switch to English. No problem. Okay, I think it's been broadcasted, so I think everybody that wants to be here is here, and if not, then they have some time to join during my talk. I didn't prepare anything because I didn't know what the audience would be like, so it will be a little bit interactive session, and if people don't know me, I'm one of the core developers of Wireshark. I've been using it for 20 years or so, and some parts of the code are mine, so I love to talk about Wireshark, and I do give training, and so when eth0 came up, I thought, well, let's do a session about Wireshark and see how it goes. I was already starting like, okay, what's the experience level of people? How many people use it like daily? Yeah, a couple. Weekly? Couple. Monthly? Yeah. Like once a year? Also people, yeah. So people that have never seen Wireshark before? Okay, good. Is there anything you want to learn today? Do you want to know what Wireshark is? Okay, well, that can be done. Okay, so basically people have used it, and in my experience, people that use Wireshark only use like a very tiny bit of Wireshark and can be taught to make better use of it, and that's basically what I want to do. So a little bit about you. Already started like, okay, how much experience do you have? Is there anything I already asked that you want to know that I can focus on this coming hour or hour and a half, depending on how much interest there is? Uh-huh. Yeah. Yeah, there are a lot of options. And you asked like how do you drill down from a large PCAP to what you're interested in, so that's something I can focus on as well. So let's focus a little bit on filtering, using the conversations, the follow stream, profiles, columns, filter buttons, stuff like that. That might be interesting for you to look at. Well, a little bit about me. Well, I started, I don't know. I have my own company at the moment for 10 years now, doing troubleshooting and providing training services. So if you feel the need to contact me on these things, you're welcome to. And well, let's skip this. This is what I do in training. So this one might be nice. What's wrong in the left picture? Yeah, assuming that the scissors are not on top of the body but in the body, then that might not be a wise thing to do. Somebody left it there probably, maybe on purpose, but probably by accident. Anybody can see that that's a problem, right? So what's the problem on the right side? What? Okay, no. It's actually, I don't know what's called in English, but it's the inflammation of some muscle tissue. I don't know. It was beneath the picture because, but it might also be like something that's broken. I don't know, because I don't have the knowledge to interpret this picture. So using Wireshark is like two things. One, you need to get the proper picture, like how do you filter, how do you get the information on your screen that you need to interpret what the problem is. And the other part is knowing your protocols, knowing how TCP works, knowing what ARP does, knowing what DNS does, knowing how HTTP should look like. If you don't know that, it's very difficult to analyze. So there's two things that you need to learn. One is how to make the proper picture, how to show things in Wireshark, and the other one is how to use the protocols. Well, we only have 1 hour, so I'm not going to focus on TCP. I can talk 2 days about TCP, so I'm not going to do that. But I think teaching you how to make a better picture in Wireshark, how to use the functionality of Wireshark to focus on the information that you need, is something that can be very useful. So that's all my slides. The rest is Wireshark. And that's always like, will it go right or will it go wrong? But so I just removed all my settings because I wanted to show you how you get Wireshark when it's out of the box. You get a little screen, and if I open a trace file, I had one open because I thought that was easy, but then I removed my settings and those, now the trace file is gone. So I need to open it again. And let's see, training. Yes, please. No, please. Yeah. Yeah, that's interchangeable. What? Yeah, people call it a sniffer trace or a sniffer. Yeah, I don't know how to. I always call it a packet trace, and I shorten that to a trace. And then sometimes people get like, what is a trace router doing? No, 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 I don't mean a trace route. I mean a packet trace. You can call it a PCAP, which is not accurate anymore because it's PCAP in G these days. So it's a different file format. You haven't known that before? Okay, since yeah, PCAP, like in I don't know when, but Steve McCann, he made the PCAP file format. He was presenting at SharkFest a couple of years ago, so I met him. It's quite a nice guy, and he made the PCAP format, and it was in a time that was like nothing, so that was how it started. And I think about 10 years ago, people started to make a new PCAP format, PCAP NG, because in PCAP you only can store frames of one link layer type, so either Ethernet or token ring or wireless, but not all of them. And so in PCAP NG format, you can store packets of different link layer types. You can store name information, name resolving information. You can store, since very shortly, you can store session keys from TLS sessions. You can store in there, and so it's a very extensible file format. So Wireshark uses PCAP NG since 1.8 by default. So you haven't noticed it, but it's a different file format. But you can still call it a PCAP. I do too, yeah. Let's see, Wireshark Workshop, traces, and there's a nice one there. So, yeah, please ask questions because I like interactive sessions, and when something takes too much time, I will ask you to ask it during dinner again and or after the session, but usually I do like the interaction. So when you start Wireshark, and that's what basically all people know, I think, in the room, is that you have like a list of packets. Let me make this larger. You have the list of packets. You have the detailed analysis of Wireshark, like what every byte and bit means. So if I click on, I open this up to something like the DSCP value, you can see in the blue here which bytes in the actual packet were responsible for this piece of information. Well, that's the basic part of Wireshark. And somebody asked, like, okay, what are these colors then? That's just a rule set that says, okay, if a packet matches a certain pattern, then it will give a color, so it's easily recognizable. We will gonna look into colors later because you need to have knowledge about filters. But first, let's go back to, okay, what do you do when you get a packet capture file that you haven't made yourself? Because sometimes you get a packet capture file of somebody else. What are the steps that you do to start analyzing that? You start filtering, okay, yeah, that's one way of looking at things. Yeah, so basically I hear like filtering and stuff. I tend to do something different because I want to get a feeling of what is in this capture file, and if I start filtering already, then I lose track. So what I try to do is I look at the statistics and then the capture file properties. Like if I get a capture file from a problem that was there at 1 o'clock in the afternoon, and I see here that the capture is between 11 and 11:45, then I know this is the wrong capture file. So I get a little grasp on what's in the capture file. And something else that you see here, and that a lot of people don't know, but you can put comments in the capture file. That's in the PCAP NG format. It's new. You can put comments in. So in this file comment, I put in the mail that I received when I asked permission to use this file, because this file was created for Cyber Olympics Challenge by the EC Council. So I asked them, can I use this file for training? So I put it in there because I want to make sure that I have the license there. So that's one of the reasons why I look at the capture file properties, because there might be something like documentation that people put in there. So that's one of the things. The next thing that I'm really interested in is conversations, because I want to know who talked to who, and if the conversations are in there, if the systems that I'm interested in are actually in the trace file. And you can see that there were communications at the Ethernet layer, so some MAC addresses talk to each other, and the amount of packets that went back and forth at the IP layer. So there was quite a few IP conversations going on, but if you scroll through that, you can already see that there's one IP address that stands out. Like, okay, basically everything communicated with it 245.12, so that's something I see in here. So maybe the trace was made on that 245.12. I can see the TCP sessions. Like, okay, I see some FTP based on the ports here, some HTTP, some HTTPS, and there was something that caught my eye immediately, the lead port 1337, which is usually like a reverse shell or anything. So that's, since this is a Cyber Olympics challenge, that probably is something interesting. So that you immediately catches your eyes if you look at the conversation list. And some DNS traffic, and well, if you know your ports a little bit, this is just name resolving on NetBIOS and some DNS. So this might not be that interesting to look at, but this might be interesting. So.
Is there also a way to show the symbolic names?
Yes, you can turn on name resolution. We come to name resolution later, maybe. And if not, please ask the question at the end again, because I sometimes lose track of what I promised. So. One other way to look at the capture file is by looking at the protocol hierarchy, which creates like a drill down of all the protocols that are in there. And the previous version of Wireshark used to open this up in a collapsed way, which I kind of like better. So if I look at, so everything in Wireshark is a frame. In this trace file, there's only Ethernet frames, IPv4 frames, and ARP frames. And then IPv4 is split up in UDP and TCP, and then I can drill down even further into the protocols that are here. So if you know that there needs to be FTP in the trace file and you don't see it, it's interesting. If you know that there's not supposed to be FTP in this trace file and there is FTP, that's interesting too. So depending on what you're researching, if it's like for security or for performance issues, you look at this trace file in a different way. Security people look for things that they don't expect. I look for things that I do expect. So it depends on your way of using it. Who is using it in a security way? Yeah, in networking, like performance and okay, and application maker, software writers. Yeah, also. So you see there's a quite mixture of people who use Wireshark, and the way that you use Wireshark is different in each use case. So this is another way of looking at a trace file and getting some information out of it, like what is there. One thing that's nice about these overviews is if I filter on an IP address, I'm going to talk about filters later in a minute, but let's just assume that this is a filter that you want to use. 3, I know this trace file, I've seen it before. I just can't type. That's a different story. There you go. If I go back to the conversation list and I click on limit to display filter, I can limit this conversation, the list of all the things that are happening to packets that match the display filter. So that if you're looking for a specific IP address and you want to know what that IP address looked for or communicated with, then first filter on the IP address and then open up the conversation list. Let's see. So what kind of filters do you use? IP address, yeah, everybody does IP address. Like, do you filter on not IP address as well? No, never? No, okay. One of the things that people ask a lot of questions about is like this. Oh, not equals, I should do it correctly. And what you can see is that, well, the red in the filter display filter bar means like it's an invalid filter, The green means it's a valid filter, but what does this yellow mean? It says deprecated, or it may have unexpected results, and that means this filter might not do what you think it does. So to me, if you read it out loud, IP address not equals 192.168.245.3, you expect that this IP address will not be visible in your packet list. But if I apply this filter, and I go back to the conversations, and I limit it to the display filter, you can see there it is. It's still there. So how is that possible? Well, that's because every packet has two IP addresses, the source or the destination. And an IP address is an alias or for those two fields. And what the filter literally means is show me all packets where there's at least one field with the name IP address that does not have the value 192.168.245.3. So either the source is not equal to that or the destination is not equal to that. So every packet will match. You can see that here as well in the status bar. You have like in total 33,247 packets, and of those 32,225 are displayed. And that's because some packets are not IP, so they don't have an IP address. So the ARP packets are not displayed. So basically, this filter that's why it's yellow, because Wireshark knows that this can be something that you don't expect. So the proper way of doing that is to put the exclamation mark, the not, in front of the IP address. If I do it like that, then if I look at the statistics, conversations, then, oh, I forgot to do that last time as well, but you have to trust me that it was still there. So if I now look at the conversations, and then it's not there. But so remember, if you want to filter something, if you don't want to see something, put the not in front of it, and then add stuff that you don't want to see. That's the basic rule of thumb to do this. Another filter that can be really useful is to filter on a certain field. Like if I filter on HTTP cookie, I will get all the HTTP requests that have an HTTP cookie. But some protocols like TCP, if I filter on TCP flags.syn, you might expect to see only SYN packets. Like in a three-way handshake, you have the SYN, SYN ACK. And so every conversation starts with a SYN packet. But as you can see, I do see the SYN and the SYN ACK. That might be correct if you do this filter. But this ACK, it doesn't have the SYN flag set. Why is it still displayed? It still has, it's still in the TCP header. If you look in this TCP header, so there's your flags. There's still a variable tcp.flags.syn, but this variable can have the value 1 or 0 depending if it's a SYN packet or not. So for some fields that are not always present in a certain protocol, like HTTP cookie, not every HTTP request has a cookie. So that's a filter where you can just say, okay, show me all fields or packets that have this field. In this case, you need to say, I want specifically that it's 1, because I'm only interested in the SYN and the SYN ACK packets. So that's another way of filtering. You can either use the filter name itself, if it's not always present. If it's something that's always present but you have to look for a specific value, then you can do it this way. I'm going really quick because I want to give you as much information in this hour as possible. So if I go too quick, please slow me down. Another filter that I really like is, let's do it on a TCP port. It might be easier. TCP.port in 80.443 or maybe 127 till 139. And then there's an error somewhere. And then that's TCP. Why is there an error? It should work. What am I doing wrong? Oh, it's a syntax error. I should use that. So this is the filter, TCP port in 80.443 and then 137 column dot dot 139. This means the TCP port must be either 80.443, 137, 138 or 139. So if you have like HTTP in your network on 8000, 8080, all kinds of ports that you want to include, you can do it easily this way. Or if you are interested in DNS traffic and HTTP and HTTPS traffic, this would be your filter. And all non-DNS, all non-SSL, and all non-HTTP traffic will be filtered away. So that's also a very powerful filter to use. And let's say I want to add this to my, because I want to, this is a filter that I might use like extensively. So there's a way to add this as a button, and there's this little plus sign. It will create a dialog where you can enter a name. So this is like web traffic, for instance. And I can make another filter like HTTP request or HTTP response. Apply the filter. I don't need to apply it, but just to make sure that you see what it does. Now I see all the HTTP traffic, and another one. Actually, the web might not be a good name for this for the other filter, but let's do it this way. Now I can switch between those two filters by just clicking on the button. And that's really something that really makes things quickly. Another filter that's interesting in that regard is TCP stream equals TCP stream. And you say, what? What does this do? Well, basically, or the way that you should read it is, for the current, like, let me do it this way. This part of the filter, the blue part, means look at the current packet, extract the value for the field TCP stream, and then match it to TCP stream. So this means all packets that belongs to the same TCP stream will be selected. Of course, this is like a lot of typing to use this filter. You can also like apply as filter here. I'm going to show that in a minute, but I could have done apply as filter on this one. I'm going to show that later. But the beauty of this filter is I can make a button out of it. So if I create a button, and I usually put a hashtag in front of filters that have dynamic content. So hashtag TCP. That means if I now look at my HTTP requests, and I think this is an interesting request, I can just click on this button and I get the whole stream of this HTTP request. Oh, this is not so interesting after all. Okay, I'll go back to all the HTTP requests. And now this one might be interesting, and I'm going to follow that stream. So this is a very easy way to navigate through your packets within a trace file. One thing that I mentioned is like, okay, I could have done it differently by using apply as filter. What is that? Have you used right-click filters before? Yeah, some people don't. You can click on any field in Wireshark, like for instance, let's say this port number, source port number equals 2470. What if I want to filter all those packets that have that port number? I can just apply as filter selected, and it will filter on that port. And now I'm not interested in, for instance, I don't want to see all the packets that have a push, or I also want to see all the packets that have a push flag. I can do apply as filter, and then extend that filter with these 4 buttons. So I'm going to do end selected, and it will show me all the, in this case, 2 packets that have the push flag set and are from source port. So you can extend that by using your right mouse button, which is kind of quick as well to create filters. Let's see. Yeah, something that if you're looking for information inside a packet, like maybe HTTP host, so HTTP host contains Amazon, it will mean that it's a case-sensitive search for the word Amazon in the HTTP host header. As you can see, there's quite a few host headers that have Amazon in it. If there's a field that has like case-sensitive information, like let's see if there's a cookie here that might be interesting to, or the user agent, Mozilla has a capital in it. If I do HTTP user agent contains Mozilla, then it won't work because Mozilla is written with a capital. And if I don't know how it's been capitalized, I can change the value of user agent with the function lower. So we'll take the value, put it to lowercase, and then I can make a comparison to something that's all in lowercase. So in this case, everything that has the text Mozilla, in what case whatsoever, will be displayed as well. So that's also a filter that I use a lot. Yes, please. An undo button? I think this, yeah, there's an undo button that you can navigate to the previous packet that you selected, but there's no filter undo button. But one way of doing that is if you press, if you have the your cursor in the filter bar, you can press. Hello, ghost in the machine. You can press your arrow keys and you can browse through the filters that you have used before. So that might, it's not really an undo, but it gives kind of the functionality that you can have with undo. So if I do that again, then there's the non-displaying version. One of the things that I changed, this is like filtering, what you start doing straight away. One thing that I don't like about the default of Wireshark is the way that the screen is being built up. If I get the packet list back with its cross, I get the whole packet list back. As you can see, I have a lot of information here and a lot of white space here. If I open this up, there's still a lot of white space here. There's still a lot of white space here. So what I usually do, even if it's at the destination of a colleague of mine, if I need to look at a trace there, I always change this first. So I can't look at it this way, is I change the layout. What does that mean? I can choose between these 6 permutations of the layout, and actually I only use these 2, and I kind of don't, I can't imagine people using these 4. But then I was I watched a presentation of somebody else who said, oh, I really like this one. So your mileage may vary. Of course, you may choose your own organization, but this is one that I really like because it really uses all my real estate on my screen. I now have less white here and well some here, but as you can see, I use this a lot to change what I look at. There's a good moment to talk about screen. If you change this, there's a screen of a keyboard shortcut like Shift, Command, W, and it will change the resulting screen in equal parts. Also, if you change column width, like this, and it doesn't show anything nice anymore, you can use Shift, Command, R, and it will change it back to a way that everything can be shown on the screen. I've got some cheat sheets here for you to take away of all the keyboard shortcuts. So go get them and take a few if you want to distribute them to other people. Feel free to take some. Some keyboard shortcuts are really handy. Like, for instance, if I want to change the time that's been displayed here, now it's seconds since beginning of capture, so it starts at 0, and then it just adds up to how long the capture takes. If I want to use, if I want to show that in wall clock time, I can use the time display format under View and then say time of day. As you can see, there's also a shortcut. This is the Macintosh shortcut, Command Option 2. In Windows, it's Command, or sorry, not Command, Control Alt 2. So you will see the shortcuts here, and they're also on the cheat sheet. So if I do it like this, it takes like 1, searching, 2, and then 3 clicks. And usually you just want to look at it. Well, so if I do it like this, oh, that's the wrong one. And I already forgot it. I need to read my cheat sheet more often. It's only the 2. So it's 2 or 4, and you can switch with it real easy. And you really need to get it into your system. You see that I use Wireshark every day, and I still don't have those in my system because yeah. Okay, so where were you? One of the things that is, well, there's a lot of missing, but one of the fields that should be in the default columns of Wireshark, what fields are you missing in this display? Like you see like the number of the packet, the time, source, destination, protocol, length, and info. What kind of fields do you think should be added here as well? Source port, destination port. If you're analyzing the TCP and UDP packets, that might be something interesting. Something else? Time since previous packet, yeah. I think if you're doing performance analysis, and then timing is really important. So adding a time field to show the difference between the packets is something that I think should be default. But it's a good example to add it. So one way of doing it is going to the preferences. So it's either edit preferences on the Windows or file in Linux and file Wireshark preferences on the Mac. And you can go to the columns, you can add a column, and now we're going to run into a nice little bug. If I add a column delta and I choose from the predefined fields, I choose delta time displayed. The delta time is like the delta time in the capture file. So whatever it's displayed, it will still show the delta as it was in the file. But I'm, of course, interested in how it's shown on the screen. So I want to do delta time displayed. And if I move this column now to the place where I want it, the last column will be deleted. That's a bug in this version, so that needs to be fixed. I'm not sure if it's there in Windows or Linux even, but at least on the Mac it's there, so I need to re-add the info column by hand. Like the first time, I go, did I delete something? But it's actually a bug. It's off by 1 error, probably. So now I have this delta column. Everything that you change in the way Wireshark is displayed is by default saved in your default profile, and you can make different profiles for things. So I'm going to talk about that later. But this is a delta column that I created by hand. But you can also add columns like if I have the IP TTL, if that's something that's interesting for your analysis. You can open up here the IP TTL, and you can also add a column by using apply as column. So we had an apply as filter, and we have now apply as column, where you can just say, I want to have this TTL field in the columns, and if I think it's more appropriate to do it here, I can just move them around. I can sort on it. That takes a while. Come on, it's not that difficult. There we go. I can put it in the middle if I want, align center, and you can just. One thing that you already saw here, if I scroll down, let's go to the last packet. You see some dots here, like it can't display it in the width of the field. That's where you have this button for, and that was the same as the Shift Control R. It will resize all the packets. So every column has the full information visible. So that's something that really is handy. If you see some dots, Shift Control R, and it's fixed for you. So yeah, let's move on to profiles, because you saw me editing the layout. You saw me editing the delta of the columns, and you saw me editing some filter buttons. You can edit more stuff, but everything that's being saved is in the default profile. As you can see, I've got a lot of profiles. I give a lot of training, and I have some interesting and useful profiles. Like it's very quickly to switch between filters by using these filter buttons. It's very easy to switch between ways of analyzing by choosing a different profile. So if I put, for instance, the TCP profile that I made on, you see that change immediately into a screen where I have my TCP stream number, I have my TCP flags, my window size, my bytes in flight, my sequence numbers, etc. Actually, this screen is the resolution of this screen is not that big because it's only 1280, and I have 1980 on my screen, of course, of 1920. I wish there was a laptop like this wide, because I always have like all the columns that I need, and that's because if I scroll through these packets, you can also see that the colors have changed. I'm going to talk about colors later. If I scroll through these packets, some things stick out because they're in the packet list. If I need to look into here to see the MAC addresses, for instance, because they're not shown at the moment, I need to open this up, look at the MAC addresses, then click on another packet, look at the MAC addresses. So everything that's in, oh, actually the MAC addresses are there. No, only for the R packets, of course. But if you're analyzing something, put as many columns on the screen that you can have that are interested for the analysis that you're doing. And then it gets really interesting if you make different profiles for different troubleshooting tasks. So if you're troubleshooting HTTP, put the host header, put cookie information, or put that kind of information in a column. If you're analyzing TCP and you need to look at the sequence numbers, put the sequence numbers in. And that's where using profiles really can make an advantage into quickly getting to the stuff that you need. As you can see, I have all kinds of filter buttons now for analyzing TCP. Give me all the SYN, FIN, and reset packets. Give me all the SYN packets. Give me all the retransmissions. Or maybe packets where there's a zero window condition. So it's, and if there's no zip traffic in this capture file, but if I open my zip profile, there wasn't any zip traffic here. Oh, it's still if I open it, maybe there's I think there's a voice call VoIP. Now you see like the call ID, the method for registering, and the result code, the user agent or the server, and I have like, okay, I want to have all the invites, so all the calls. From this call, I want to have all the signaling and the RTP, and you get all the signaling and the RTP within one button instead of having to filter that yourself. So basically, if you use Wireshark quite a lot, then it's very interesting to build some profiles that match your way of working. And the proper time to do that, because I'm a teacher, so I teach that and I don't do it myself. What I notice is if you analyze something, you don't have the time to, you just want to fix your stuff, so that's not the time to do it. But once that has been done, then take 15 minutes to see, okay, what did I do in this case? And now the problem is now solved, so I have some time. Now I create a profile that will help me the next time when I need to analyze such a problem. So that might be a good workflow. Like every time you solve something, yeah, adjust your profiles to make the next time more easy. Let's see. Yeah, question.
Is there a reasonable time to capture? Will the tool become very slow?
Good question. Yeah, can you capture forever, and what will happen if you do? My rule of thumb is like 50 to 100 megabytes of PCAP traffic is doable. Then your filters will be a little bit slow depending on what's in the traffic, but it will be doable. If you load a trace file of 500 megabytes or 1 gigabyte, then you need a very beefy laptop to be able to work with that.
But how much time is it?
It's not about time, it's about the amount of packets that are in there.
I understand. It still doesn't give me any clue on if it's 10 seconds or 5 hours.
That depends on your network, how much traffic is on your network. So what I usually do when I make a capture file, so let's go to the capture options. If I want to capture on my Wi-Fi interface, I have here the output options. If I fill in a file like test, and then I can say create a new file after, for instance, 100 megabytes. and it could have been easier like this, 100 megabytes. And then I say, I want to keep like 10 files. And that means it will start a file, create a new one after 100 megabytes, create a new one, and then after 10 files, it will delete the first one and create the next one. And that you can capture like this forever until the problem occurs. And then you don't know how long each capture file will be, but at least you know your disk is not filling up. So that's the way I do that. Yeah.
You said you can capture until the problem occurs. Can you also automatically stop capturing when the problem has occurred?
No, not within Wireshark. No. Of course, you can do some scripting at post-process your files, or if there's a trigger somewhere, and then just kill Wireshark, but that needs to be external, not within Wireshark. Yeah.
This feature for digitizing is capturing on the network interface on the laptop.
Uh-huh.
Sometimes it's on a server somewhere deep in the network where you don't have Wireshark. Is something possible with like this with TCP?
Yes. Yep. No, you can use TCP dump. That's with minus capital C. 100 means create a new file every 100 megabytes. And then recent versions of TCP dump, I think the last 2-3 years ago, or maybe 5 years ago already, there's that capital W, which means if I do 10 files, it will rotate over those 10 files. And I think there's also, if you want to do it time-based, there's capital G, and then, for instance, 3600 for 1 hour captures. Yeah. So you can do that with TCP dump too. Yeah. Okay. Let's see.
All the data is saved, right? So if a person is downloading, then all the downloaded data will also
By default, every packet that's on the interface that you capture from is captured. So if you want to restrict it to something, you can use a capture filter. As you can see here in the input, I can enter a capture filter. So if you're only interested in oh, that's a display filter. If I'm only interested in 10.0.0.1, I can put in a filter like this. Yeah. I tend to not use capture filters because when I'm analyzing something, I don't know what I'm analyzing. So I kind of tend to capture everything and then filter afterwards by display filter. If that's too much to save to disk, then I tend to look at, okay, which hosts are not interesting and communicating a lot, and then I say, okay, if this 10.0.0.1 is watching at Netflix, I can just say, okay, I don't want to have that in my trace, and I can put some host in there that I'm not interested in, because sometimes your ICMP packets or your R packets or your DNS packets, which are not in your filter if you do only host 10.0.0.1, are the ones that give you the clue why things are going wrong. Yeah. Okay. By the way, do you know what promiscuous mode means? No? Well, in real life that's something different, but in Wireshark, it's normally your Ethernet card, it will only listen to packets that are destined for your own MAC address, or the broadcast address, or the multicast addresses that it has subscribed to. So if you put Wireshark, if you try to capture on a span port of a switch, so you copy traffic from one port to another port, or one VLAN to one port, then those packets don't have your MAC address. So by default, those packets will be dropped by your network card. And that's why you need to put on, and by default, it's enabled, promiscuous mode. It means your network card will listen to anything, and it will just pass it through. So if you use a span port and you don't see the things that you're interested in, you might want to check if your promiscuous mode is turned on. Let's see where. Interesting. You're a software developer? Yeah, for the BPF filter is also built by Steve McCann. It's a little virtual machine inside your kernel. And why is it a little virtual machine inside your kernel? Because if you want to do capture filtering, it usually means that you have a lot of traffic and your system is overloaded by the amount of traffic. You want something that can filter the packets without moving them to user space. So there's a little virtual machine inside your kernel, and this is the language of your virtual machine. So in this case, load 2 bytes at precision 12, which is the ether type, compared to the ether type of IP, which is 0x800. Then if it isn't IP, jump to 6, which means I'm going to look at ARP. So let's make it a little easier. IP host. That's an easier filter. So look if it's IP. If it's not IP, go to 7, which means I'm done. Don't capture. If it is IP, I need to check the IP address. So I'm look at the source address. If it's 10.0.0.1, then I'm done. I can capture it. If it's not, I need to look at the destination address, etc. Well, and you can make it very difficult. If you do TCP port 80, it gets a lot more difficult because now you see that it needs to compensate for headers that have a variable width. So it needs to get the length of the IP header, calculate that, and then move over that, and then see in the TCP header where port 80 is. So it can get really complicated. But at least you have a way of, if your filter doesn't do what you think it needs to do, then you can check, okay, what does the filter actually do in the kernel, and then maybe you need to rewrite your filter. If you ever have problems, I've got this strange fetish that I like capture filter building. So if you ever have a problem with the capture filter, feel free to email me, and I'll try to help you. Okay, so that's capturing. So we covered, colors. We didn't cover colors yet. You can see in this profile where there's voice traffic has a different color scheme than we had in the default. Also, if I go back to the TCP colors, and I filter on TCP for a moment, which is not in this trace file. Okay, go to the last one. Let's see. No filter. You can see that I have different colors here as well. Colors are also saved in your profile, and you can change the color, the way colors are using by going to the coloring rules. In this case, I deleted all the standard stuff that I'm not interested in, and I created some new filters for myself. And it's basically like a firewall rule base. It goes to the first coloring rule. If it matches, it colorizes the packet, and it's done. If it doesn't match, it goes to the next, etc., until it finds a matching filter. So in this case, all my TCP reset packets will have the red color. All my SYN will have the blue color. SYNX will have, the green color. All the SYNX will have the green color with blue text in it. My FIN packets will have blue, etc. And of course, if I change to the other profile, and I go back to the coloring rules, let's give it some time. Yeah. There you see I've got a totally different set of rules. One thing that you see here, it's called opvallend, it means stand out, is I usually have like an opvallend or like a very strong color that I can enable by clicking here, and I can type in a filter like say something that I want to have really focus on. So if I do it like DNS traffic in this case, and you can quickly see I can scroll through 30,000 packets like this in a few seconds, and you already get an overview of where the DNS packets are. You can, in this right side, you might have not seen this before or not took a real close look at it. This is actually a preview of what's coming. So this is the whole capture file, or not the whole capture file, it's 1 pixel per packet. And if you scroll down, you will see like these packets correspond to these, and if I scroll down, I will see these coming by. These will come by if I scroll down more, and so it's like a preview of what's coming. So if you change your background color to something that stands out in like this purple one or the magenta one, who was in the color presentation before here, it's a lie, but that's something different. So that you can use that to make things stand out, and something I sometimes also do is create like a white background with a very light gray text to make things disappear. So I do want to see them, but I don't want to like have them really subdued, so I can then use a gray, like if I, let's create that coloring rules. So, and another one, by default is not enabled, which I think is a bug. Like this is grayed out, and then I say I want all TCP.ports in 8443. I don't want to see that, and then I create a foreground color, and I choose like very light gray, like there. And the display filter is gone. Okay, TCP dot. I think that's also a bug. If people want to help in fixing bugs, if you can program C, then you can help out. Okay, there it is. You see, it's already grayed out here, and now all the non-port 80 and 443 traffic stands out, all the DNS traffic stands out, so this is a way you can help yourself in finding the things that are interesting. If a certain cookie is interesting, or a certain port, or whatever, make a really bright filter for it, or color for it. Let's see, what didn't I cover? There's a lot of things that I didn't cover, but are there any questions so far? Things that I... Okay. Yeah?
If you have a huge filter file and then you think I'm interested in one particular host,
Uh-huh.
can I then filter the thing and create a new file? with
Yes.
only that information?
Yeah. So let's say I found IP address equals 192.168.245.3. Let's say this is an interesting host that I want to look at more specifically. If it's a really large file, so I want to save this in a different file, then it's actually not save as you might expect. It's actually export specified packets. And then you can create a new file like temp. And if I open that file, temp.pkapng, and now if I remove the filter and go to statistics conversations, you can see that every conversation is actually from this, from the .3. Yeah. Okay. I showed you how to use them, and good point. Right mouse click on profile here, and then create new, or say manage profiles. If you want to copy one, let's say I want to copy the TCP one that I already have, I can press here the copy button, and it creates a new copy, and then you can change it. One other way is to go to view, and then conversation. Let's see, where are the profiles? Is it in edit? Yeah, configuration profiles under edit. That helps too.
Can I find profiles of expert users?
There is one guy that has like a whole list of profiles. I can't remember what his website is, but there are some profiles. If you look for Wireshark profiles online, you can find some profiles. What I do suggest is that you look at those profiles, use them a bit, but change them to your own liking, because everybody works in a different way. So please learn from what I'm doing. This is my way. Of course, it should be your way, but you probably have a better way for yourself. So please use your own way. No, but you can export it by going to About Wireshark. No, that's not Wireshark. There we go, About Wireshark. And then if you go to folders, it will show you where your personal configuration folder is. If I double click that, it opens in File Explorer or in Finder. And then there's a folder called Profiles, and here you see all those profiles. They're just directories on your disk. So you can just copy it, zip it, and send it to somewhere else. There's actually, I think it's in 3.2, there will be an import for that you can import a profile. We don't have an export yet, but probably will appear somewhere along the lines as well. Yeah. Okay. Let's go back to the trace file. One thing, somebody said like follow stream. Who uses follow stream? Who doesn't use follow stream, and what the hell is it? Good. It's always nice to be able to show something. Let's go back to my, yeah, following, yeah. So if this is a trace where I thought, hey, there's something interesting in 1337, because that's not a normal port, it's usually like a backdoor. So, well, if I want to know what happened on that stream, what was the content of that stream, I can use the follow TCP stream. So you go right mouse click, follow, and because this is TCP, you can only select TCP stream. If it's UDP, you can select UDP stream. If it's SSL and you did SSL decryption, you can do TLS stream. And so in this case, I'm going to do follow TCP stream. And now you can see that this is actually a reverse shell, because you see that there's you can see like there's an interactive session in here. The colors are like, the blue is from the client to the server, which means the one that initiates the session, that's the client. Could be a server, of course, doing that, but the one that initiates the TCP session is in blue, and the other one is in red. And then you can select one part of the conversation, one flow, by changing it. So if I do it like this, I can see all the commands that were typed in, and all the output will be in the other one. And of course, let's go back to this one. Of course, you can save it in a new file if you're interested in building a report out of this. Not in follow stream. Follow stream just shows the content without any timing. You lose that information. Yeah. Yeah. Yes. Not by default, because of course, like Wireshark gets it from the net, close to the network card. So only your browser knows the unencrypted stuff, but your browser can export the TLS session keys, and Wireshark can read the TLS session keys, and then you can decrypt the traffic. Is that something you want to see? Yeah. Oh. Okay. Let me get a sip of water then. Because this is something that live demo is always like interesting. Yeah, that's why it's interesting. So if I'm going to use Chrome, like now I did it wrong because I started Chrome already, and you need to set an environment variable. So I'm going to quit Chrome, and I'm going to export. Let's do it in the one that I had prepared here. So you need to set an environment variable, and it's the SSL key log file. And I'm going to do it like, okay. So now, whatever I start from this shell will be using this keylog file. So applications, Google, Chrome, contents, and then it's, I think it's in macOS, Google Chrome. You can make like a shortcut for this, but I don't have that. So if I open this up, now everything that I will look up in Chrome will create that file. So if I'm, I don't know, www.nu.nl, it will switch to HTTPS. And if I look at this trace file, I need to have another session here. Let's see. Yeah, it has been there for a couple of years. Actually, in Firefox, it works as well. But then there were a couple of versions that it didn't work, and the Firefox that is out now, it works again. But there were like in between like a couple of versions that didn't have it enabled. So let's go back to this directory. Message file directory. Why not? Okay. You don't want food. No food. Let's see. Traces where the SSL keys are there, and if I tail that SSL keys, food is enabled.
Food is ready.
Okay.
How much time do you need?
How much time do you want? I can stop now, or can let
Not now.
not now. Okay, there's a cliffhanger, so let's give it like 10 minutes or so.
10 minutes, then you're welcome to join us in 10 minutes.
Okay.
Great.
So let's tail this and go to website, and you can see that it's growing. Let's see. So if I go like I go there, you see all the session keys. You have like the private key of the server, and you have session keys. Like the private key is only used depending on what kind of TLS settings you use, but the session key is actually an ephemeral key just for that specific session, and those are created in this file, so I can decrypt everything that I capture at the moment. So if I'm gonna capture here, capture options on the Wi-Fi interface. Let's delete this. I don't want this. I don't want a name either. Okay. So let's start a capture, and let's go to where. Anybody wants to fill in their bank details now? No? Why not? So let's go to yeah. Yeah. Yeah, of course. But let's go to the Rabobank, for instance. Go to inloggen. I'm not going to log in, but let's say I'm using 1, 2, 3, 4, 5, 6. I don't know. This doesn't work, but there's already packets from the Rabobank, right? So if I'm going to stop this, and now I'm going to change my profile for TLS. Since Wireshark 3, we call it TLS instead of SSL, which is more correct, because SSL shouldn't be used anymore. If it is used anywhere, then you should backslap them. In those preferences, so let's open the protocol preferences. In the preferences for TLS, there's a field called the pre-master secret log file name. And if I point that to this SSL keys that I just created, some decryption will happen. So let's see if there's TLS traffic. And there is. And there is my HTTP. So it's within TLS, there's HTTP. If I do http.host contains Rabobank, if all goes well, there should be like the Rabobank traffic that was just encrypted. Not anymore. In an RSA key exchange, the session key is encrypted with the public key from the certificate and then sent to the server by the client. So if you have the private key, you can decrypt that session key transfer. But with Diffie-Hellman key exchange, the exchange of the key, the session key, is not based on the private key anymore. So in that case, you need either endpoint, either the client or the server, to lock those keys, and then you can do decryption. So I don't know of any. Well, you can change the OpenSSL library to lock those keys. So if you have a server that uses OpenSSL, you can have that lock the keys. But not many. It will become a problem. So that more and more servers will be able to lock session keys for debugging. But at the moment, it's just on the client side that you can do it. Yeah. Okay, it all went very quickly, but I wanted to show you some interesting parts of Wireshark that I think should be used and a lot of people don't use. So, any more questions for now, before dinner? Feel free to ask me any questions during this weekend. Who, Dimitri asked you? Okay, is he here? No, he said 88, right? Yeah. He's playing with lasers. Yeah. Yeah, I think I could. I'm going to talk to Dimitri about it. Yeah. Yeah.
How hard is this and how would you add another protocol?
Okay, so a protocol dissector, it's not, it depends on where you come from, of course. If you have no programming experience, then it's really hard. But if you know programming, there's quite a good developer guide. There's the source code, I think, is pretty readable. So it's not. No, there's no. There is a generic protocol detector that you can make, like a config file, like this field is 2 bytes and it needs to be interpreted this way. I haven't used that, but it's available somewhere. You can also write a Lua script. So, but then it already gets a little more complicated. So it's not really easy. Like, okay, I'm going to point at this these bytes, and now every time you see these bytes at this position relating to TCP, it should be this. That's not there. Would be an interesting option for reverse engineering stuff and so on, but it's not there yet. No. Okay.
Can Wireshark act as a proxy to capture traffic from other devices?
No. Then you have to use man-in-the-middle proxy or polar proxy or any other system. Yeah.
I got a question after this.
Good. I'll be available. And please take cheat sheets. I don't have business cards with me, but there's my Twitter handle. So if you need anything, and if you look my domain up, you can find me. And if you have any questions, I'm always willing to answer that. If I get like 20 questions, then I might want to talk to you about, like, maybe you want to hire me. But I love helping people get the most out of Wireshark. So feel free to email me. Okay. I think it's dinner time then.